Namaskara champions, ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? So this is your Premila Ma'am and today we are going to deal with the basic brochure session for PUC 1. I know there are a lot of students here who are just studying their 10th or completed their 10th. They can see that from 10th to PUC 1, they have a very big jump to move ahead. And we are going to make sure that this jump is not maximal, it is minimized to a smaller extent so that you feel PUC 1 very easy. This session is going to reduce the space, reduce the time lapse between 10th and PUC 1 so that once you start your PUC 1 now, it will be as easy as a cake for you to slide down each and every chapters. So yes, without wasting any time, let's get started with the video. First of all, if we talk about the chapters of your PUC 1, I can see that starting from some basic concepts of chemistry, we have like 5 chapters under physical chemistry, like some basic concept, atomic structure, thermodynamics, equilibrium, and redox. We have 2 chapters for inorganic, which is classification of elements and chemical bonding. Also, we have 2 chapters for organic, which is GOC and hydrocarbons, general organic chemistry and hydrocarbons. So, I'm going to tell you what are all the very basic things which you have to know before starting all of these chapters, because trust me, you know, in your PUC 1 exam, 70 marks is from theory and 30 marks is from practical. Practical, let us keep aside. Let us think that yes, we will get 30 marks there. But in order to get 70 out of 70, you have to give your heart and core, and for that you have to know your basic. Ma'am, I'm not interested in getting high scores in PUC. My main aim is to crack KCET or NEET or JEE. If you are that kind of a person, then let me tell you one thing, my dear champions, even your PUC 1 syllabus will greatly help you with all of these preparations, be it COMEDK, be it KCET, be it NEET, or be it JEE. Your PUC 1 preparation is going to make sure that you have a very good score in all of these entrance examinations. Because if you talk about KCET, nearly 30% of the syllabus is from PUC 1. If you talk about NEET or JEE, nearly 50% of the syllabus is similar to that of PUC 1. So yes, PUC 1 is not just going to give you marks in your school board exam, my dear. It is also going to help you a lot with your entrance exam preparation. So I'm telling you, this is very, 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 very basic. You have to make sure that you have a good stand on your basic. So when I talk about basics, one thing which strikes in your mind is periodic table, periodic elements. Ma'am, when I look into the periodic table, I can see those many elements, 118 elements present in the periodic table. How can I remember that? Dekanna, I'll give you the most simplest, easiest trick to remember this. Do not worry. I'll come up with a separate video for that as well. But as of now, just understand that periodic table is super simple and super easy. Ma'am, how do you understand or how do I understand the basic concepts or the basic crux of periodic table? My dear champion, always remember this thing, that your periodic table is divided into 4 blocks. One is S block, the one which I am marking now is S block. The other one on the other end, this group is called as P block. And the one which is between S and P block is actually this green one. Now, this is your D block. And the one which is kept in the bottom, this set is called as F block. Why do we call them as S, P, D and F block? Because those block elements will have their valence shell or their unfilled shell as S, P, D or F blocks. F orbitals. Say for example, if you take all the elements in S block, they have unfilled S orbital. If you take all the elements of P block, they have unfilled P orbitals. If you take all the elements of D block, they have unfilled D orbitals. And if you take all the elements of F block, they have unfilled F orbital. This is why you say that that block has the concerned name. It is not so random. It is there for a reason. The name is there for a reason. Fine. Ma'am, I'm clear about what blocks are. But could you please tell me what exactly is that group number, period, so on and so forth? It's super easy, Rakanna. Always remember, whenever you go in a periodic table, whenever you go from up to down, whenever you go in a downward motion, that collectors is called as a group, right? That collection is called as a group. Similarly, if you see from left to right, if you align them from left to right, that is called as period. So quickly tell me how many periods you have here. You have 1, 2, 3, 4, 5, 6, 7. 7 periods in total. How many groups you have here? Starting from 1 to till 18, you have 18 groups here. So you have to understand this. You have 7 periods and 18 groups in total. Ma'am, why are you not considering this F block element? Why is it so lonely? You are not considering it either in period or in group. Why, ma'am? The reason is your F block is actually kept inside this two blocks. I mean, these two spaces. If you see lanthanum here, okay, if at all you see lanthanum here or lutetium here, you have to understand that inside this one space, you have your entire lanthanum series of F block kept one after another, one after another. Similarly, if you take Lawrencium, the place where actinium group is completely present, the entire element is kept one after another, one after another in this way. You get my point? Right. So this is all you have to know about periodic elements. I'll come up with a video in order to understand or in order to keep all these 118 elements in hand by very easy tricks. It is coming soon, but as of now, just understand the basic concepts. Fine. We have completed the periodic elements. What are all the nature of periodic elements? What is the basic block which we have to know? What do you mean by a period? What do you mean by a group? Other than this, you should also understand one concept that S block is mostly or completely made up of metals. Whereas as you go from left to right, from S block to P block, the metallic character decreases, which means non-metals are mostly present in P block. So, in an overall way, I would say that my metallic character decreases as we go from left to right. If metallic character decreases, the electronegativity of an element increases as you go from left to right. Similarly, electronegativity of an element decreases as you go down the group, since their size increases down the group. Ma'am, what do you mean by electronegativity? That is what we are going to talk next. We are going to understand what do you mean by electropositive element and an electronegative element. Dekana, the concept is so simple. Electro means it is electron. Positive means it has excess of electrons. It has excess of electrons or unwanted electrons in hand. That is why it is called as electropositive. Similarly, electronegative, electro stands for electron, negative stands for, less count of electrons, which means electropositive elements are those elements which have excess electron and those who are ready or willingly available to provide, share, donate the electrons. Electropositive elements are simply electron donating groups. They donate their electrons. Example, if you take any metals, why are metals called as good conductor of electricity? Because metals have excess of electron which will help in the flow of electrons. So all the metals are said to be electropositive in nature and they are electron donating in nature. Similarly, if we talk about electronegative elements, the elements which want electron, the elements which withdraw electrons, electron withdrawing groups are called as electronegative. Example, all halogens, be it fluorine, chlorine, bromine, iodine, or even oxygen, they are all electronegative. Why? Because they are all electron withdrawing groups. They get electron from another atom. You get my point? So, you know, in general, there are two kinds of element. Element A, say for example, element A will donate the electron. If he donates the electron, then he is called as electropositive, and element V will accept the electron or draw the electron. If he accepts the electron, then he is called as electronegative. Next, we are going to talk about oxidation and reduction. This is super easy, super simple concept, Kana. If you know about oxidation and reduction, now redox and electrochemistry chapter is going to be super easy for you. So, what do you mean by oxidation and reduction? Oxidation, let us split it into two: oxygen plus addition, which means whenever you add an oxygen to a molecule, that is called as oxidation. Ma'am, should I always add just oxygen? Is there any other case? Can I just add any other element? Yes, in case of oxygen, in case of oxidation, other than oxygen, you can add any electronegative element, or you can also remove any electropositive element. So we are going to ensure that we add an electronegative element, we increase the electronegativity of a molecule, and whenever electronegativity of a molecule is increased, there occurs a loss of electrons, right? Because electronegative element needs electrons. That is why there is a loss of electron. Similarly, if you talk about reduction, reduction is like the straight opposite enemy of oxidation. Whatever oxidation does, reduction will do in an opposite range. That is why I say in case of reduction, there is addition of hydrogen or electropositive element or removal of electronegative element, which will result in gain of electrons. So, ma'am, I have one super quick doubt. Can oxidation and reduction occur hand in hand? Yes, whenever we have a reaction, and in that reaction, if both oxidation and reduction occurs, then we call that reaction as redox reaction. In that case, your element which acts or which is oxidized will help to reduce the nearby element. Similarly, the one which is getting reduced will help the nearby element to get oxidized. That is one. The one which is getting oxidized is called as a reducing agent, and the one which is getting reduced is called as oxidizing agent. Okay, so what happens to an oxidizing agent? If I am an oxidizing agent, I am going to reduce myself. If I am a reducing agent, I am going to oxidize myself so that I'll ensure that the nearby participant is either reduced or oxidized based on the name of the agent. You get my point? Yes? Okay. Next, we will talk about acids, bases, and salt. You know, the element which releases H plus on addition of water is called as acids. The element which releases OH minus on addition of water is called as bases. And whenever you add an acid along with a base, you get a neutral compound which is salt along with water. So remember this, my dear. Whenever you have a release of H plus, it is acid. Whenever you have a release of OH minus, it is a base. Could you please tell me an example for acid? Yes, yes, yes. I know you guys exactly know what an acid and what a base is. So let me give you some examples. Say, per se, HCl, H2SO4, HNO3, CH3, COH. They are all acids. Why? Because when they have a contact with water, they will release H plus. Similarly, if you talk about bases, let me quickly give you some bases like NaOH, KOH, okay, or even barium hydroxide. All of these are said to be bases. Why? Because on contact with water, they release OH minus. So this is how you have to differentiate an acid from a base. Please keep this in mind, my dear. Never forget this concept. It is super duper 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 important. Fine. Okay, ma'am. I'm damn sure about what an acid, what a base, and what a salt is. What next? Talking about the next concept, you have to understand what a hydrocarbon is or what an organic compound is. So, generally, an organic compound is made up of two components, hydrogen and carbon. In an organic compound, other than hydrogen and carbon, you can also have any other element. It is not mandatory that you should have an extra element, but you can have any other atom present in the molecule. Still, it is said to be an organic compound. But if you talk about a hydrocarbon, in case of hydrocarbon, you just have two entities. One is hydrogen and the other one is carbon. You will never have any other atom, and hydrocarbon is very specific with what it has. It should have only hydrogen and carbon. Talking about hydrocarbons are of three types based on the nature of bond they have. And I would say the structure is alkene, alkene, and alkene. Aha! Now you know what exactly this means, right? So alkene, if you have Ane, which means the element has single bond in it. If you have Ene, which means the element has double bond in it. And if you have Yne, then probably you must have found that it has a triple bond in it. That's it, my darling. That's it. Whenever you have a hydrogen carbon compound with single bond, it is alkane. Double bond, it is alkene. Triple bond, it is alkane. Example for alkane is CH4. Example for alkene is CH2 double bond CH2. And example for alkane is CH triple bond CH. Always remember this. Always remember this. Fine. What next, ma'am? Next, talking about general organic chemistry. You have tons and tons of concepts to keep in mind in general organic chemistry. But I would say that just understand the functional group at first. Because whenever you talk about the functional group now, it plays a vital role, an extremely vital role on considering the nature of the element. Because a functional group is like a family name. Okay, say for example, I am called as Premila Muralidharan, which means I am daughter of my father Muralidharan. Similarly, you guys must have a family name, right? So that family name will make sure that or will show that you are from this family. You will have this kind of a character. Just say. Okay, say for example, if I say that all the ice creams which are present in this box is completely made up of chocolate. Some are Belgium chocolate, some are, choco nutties, some are wafer chocolates, but everything comes under chocolate, right? Yes, similarly, you consider functional group as a prima facie of identifying a nature of an element. And understand, my dear, whenever you have an OH in your element, it is an alcohol. Whenever you have a CHO in your element, it is an aldehyde. Ketone, I don't have to tell you guys, but you still know it. It is RCOR dash. Similarly, carboxylic acid, it is RCOOH. So remember this, my dear. Remember this. This is super duper 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 important. Fine. Other than this functional group, what should you know? When you start with some basic concepts of organic chemistry, you should know what nomenclature is, what an IUPAC naming system is, how will you name an element based on IUPAC system, And what are all the basic points you have to keep in mind while naming an element? But don't you worry, my dear. I'll come up with separate videos to make sure that you understand nomenclature, isomerism, reaction mechanism, what so and what not, every single part which you need for PUC 1, so that we will make sure that each and every point is crisp and clear. And yes, once you complete this bridge course, now for sure you will be able to understand the crux of this entire chapters, because trust me, I've given you a basic glimpse on what happens with each and every chapter. Yes, my dear. So with this, we will wind up this session. I hope this session was super useful for you. If you want some more details or some more data on some concepts which is related to PUC 1, PUC 2, KCET, COMEDK, whatnot, whatever entrance exam idea, you can reach out to me in the comment section below. I'll be always available to reply to you in person. With this, we will wind up the session. Thank you so much for being in the session. We'll meet you soon. Until then, this is Premila Ma'am signing off. Tata bye bye. Take care and have a great day.